So we'll go back to today's note here. Do you guys want me to use true here, or do you want to just keep pre1? Because pre1 may or may not be true. Let's just keep pre1. Let's not even make this assumption. Sorry about this. I'm backtracking a little bit here. Okay, so I'm saying make no assumptions of pre1. So we'll keep pre1, just intact as it is. So this way we cannot simplify anything. Sorry about that. Okay, so this is as much as we can do. Okay. Are you guys okay so far? Because I just made some changes to the assumption. No? Okay, not okay. All right. So what I have just done is to say let's just say that we don't know anything about the precondition. So pre1 has to remain as pre1 because we don't know anything about it. It is not true, it is not x equals 0, it is not x equals 1, it is just unknown. And that's why I cannot simplify pre1 out of the equation. Is that okay? Okay. Which makes this approach more general because now I can plug in a precondition later on and make it work for specific cases later on. Okay, what about post 2? Can we figure out the post 2 given the pre 2? Is this the kind of statement that we know how to deal with already? Okay, it's an assignment statement. The right-hand side refers to the left-hand side, and the right-hand side as a function also has an inverse function, right? Okay, so let me just write that down. On line 2, the right-hand side refers to the left-hand side. The function of the right-hand side has an inverse function. Okay. So let's just say the function of the right-hand side, we'll call it f of x. It is x plus 1. The inverse function is going to be f prime of x, which is x minus 1. Is that part okay? So we figure out how to undo the operation on line 2. As a result, we can use the substitution rule. Okay? You can only use the substitution rule if the right-hand side of the assignment statement can be undone. If it cannot be undone, then you have to use the forget rule, which basically says, I have to forget everything that I knew about that variable because I have just changed it in a way that I cannot know whether the old relationships can be maintained. Is that okay so far? Okay. So once we know all of this stuff here, we can go try to derive post 2. Post 2 is going to be the result of substitution. It's based on pre2. We find all occurrences of x, which is the variable on the left-hand side of the assignment statement. And we're going to substitute each occurrence of x with f prime of x. So in this case, we can expand the whole thing. Pre2 is this mess here, which is kind of big. And we find all occurrences of x, replace each one with x minus 1 because we are using the inverse function. But this is as far as I can go because I don't know what is pre1 or post 2. Is that okay? I think last time I also pointed out that post 2 is appearing both on the left-hand side and the right-hand side. In other words, it makes it kind of difficult to solve the equation because if I do not know what is post 2, I cannot carry out the substitution rule. But if I cannot carry out the substitution, then I cannot resolve post 2. So it's a circular type of reasoning. But we'll just leave it like this for now, and we'll focus on post 3. What is post 3? There are two ways to get to post 3. One way to get to post 3 is we come in from the top, we evaluate the condition. It turns out to be false, and we take the path immediately. That's one way to get to post 3. So one way to get to post 3 is pre1 is still true. Unfortunately, x is less than k is not true. And that's why we are exiting the loop without even going in once onto statement number 2. The other way to get to post 3 is we go through at least one iteration. We go back to this point here before we have to make a decision, and then we evaluate whether x is less than k, x is no longer less than k, and then we take the path out. But in that case, it is not pre-1 that is guaranteed to be true. It is going to be post-2 that is guaranteed to be true. Yes?
You say that you can use a substitution rule because x gets x plus 1, but if it was x gets 6, would you have to use the rule?
That is correct. If the statement spells x equals 6, then I cannot apply the substitution rule because the right-hand side does not refer to the left-hand side anymore. If you have an assignment statement where the right-hand side does not refer to the left-hand side, then there's no way to reverse the operation. There are tricky cases where you can still reverse the operation when you have a prior assignment statement right before that, so that somebody else carries a clone or a copy of the value that is on the right-hand side. Then you can still use the substitution rule, but that would be like a really exceptional case, and I'm not going to put it into this class. Okay. So getting back to post 3, if I go through at least one iteration, you can see that post 2 has to be true, but the condition of the loop still has to be false in order to get out of the loop. So just like last time, we can simplify this a little bit. We can say x is greater than or equal to k, and pre-1 or post 2. Is that okay so far? So now we'll go ahead and actually carry out. I can't do any more derivations at this point because not knowing what is pre-1 is preventing me to resolve anything at this point. But it is important to point out that post 2 is a very important condition because it almost appears everywhere. If you look at pre-2 itself, pre-2 has a component that is post 2. Post 2 itself is expressed in terms of post 2, and post 3 also has a component of post 2. And that's why post 2 is important, and it has a special name. It is called the loop invariant, which basically means this is a condition that does not change whether you are in the loop or whether you have exited the loop. It is still true, assuming that you have to go through the loop at least once. Because if you do not go through the loop at least once, then post 2 does not have to be true, because in that case, only pre-1 has to be true, and pre-1 may or may not imply post 2. But in general, a loop, for a loop, you have to assume that you can go through it at least once, because a loop that is guaranteed that you will not even go through at least once has no meaning. There's no purpose to put a loop there if you're guaranteed not to go through the loop even at least once. Okay. So do we have any questions at this point?
Did you say post 2 is the invariant?
Post 2 is the loop invariant, yes. Mm-hmm.
It have to come from pre-1 to pre-2 to post 2 and then go to post 2. That's this.
I'm sorry, could you repeat the question? I can't hear.
Right, go ahead and repeat the question just a little bit louder, please.
You said that the post 2 have to be at least go to the loop one time.
In order for post 2 to be true, yes, you have to go through the loop at least one iteration. Yep, you have to go through at least one iteration in order for post 2 to be guaranteed to be true. Because according to the picture, post 2 is guaranteed to be true after statement 2 executes. So, and statement 2 is in the loop.
The loop invariant is a variable that from the loop that occurs everywhere?
A loop invariant is not a variable. It is a condition.
Okay.
It is a condition. In this case, it is post 2. Post 2 is our loop invariant. So I'll just write down here, post 2 is our loop invariant. So are we okay so far? Okay. Now let's go ahead and make some, assumptions about pre-1. Okay. So we'll say this is case 1. Case 1 says, oh, okay, text is saying pre-1 equals x equals 0. In other words, I did something before line 1 to guarantee that by the time the loop starts, x is going to have a value of 0. Not only that, I also guarantee that k is greater than 0. Or I can say k is greater than 0 is good. So we'll plug this in. Sorry, go ahead.
So we're working out the same problem. So x less than k, but k is greater than 0.
No, we'll figure out something here. Okay. So we'll plug this into the pre and post conditions and see what happens. The first thing we'll do is we'll take a look at pre2, and pre2 has a pre1 component, so we'll go ahead and copy this part. Pre2 now equals to this mess here, except I can use this part to replace this part because I was told that pre1 is x equals 0 and k is greater than 0. So I can do something like that. Is that okay? I just plugged it in.
Because you made that, you just cut and paste, right?
Yep, I just copied and paste. Of course, it's still not going to solve the problem because we still have the circular reasoning. In other words, post2 seems like post2 still have the same problem as last time because we just made it a little bit longer this time, but it still has post2 undefined at this point. But we'll see that this is actually enough for me to go on because I can now start with a suspicion. Okay. So post2 is still unresolved. However, tech has a gut feeling that post2 may be x is less than or equal to k. Do you guys understand what I'm saying here? I only have a suspicion. I have a feeling that post2 maybe x is less than or equal to k. I don't know whether it will work out or not. Okay. Tech can now plug this in and see if it will all work out. Is that making any sense? Just because I suspect post2 is x is less than or equal to k does not mean that post2 is in fact x is less than or equal to k. So in order to verify that this is actually correct, this is a valid post condition or a valid loop invariant, I have to plug it in and see everything will work out or not. Is this part okay? Somewhat? No? Somewhat? Okay. So we'll just kind of plug it in and see whether everything will work out because this is going to be the lengthy derivation. Because now what we are doing is we're copying and pasting post2 again, but this time the inner post2 here doesn't have to be post2 anymore because I want to see if post2 can be just that, right? So I copy x is less than or equal to k and just paste it where I refer to post2 because I'm suspecting that this will all work out. Okay?